the team very thankful for the intern provided by Emertxe, and I am Avantika from the Department of BCE, currently pursuing my BE degree in National Engineering College. Uh, uh, First of all, we are going to see about the goals of internship. The goals of the internship is to learn the basic concept of embedded system and both the hardware and software requirements to build the embedded system, and able to build the embedded system in of our own using both hardware and software. The project requires the basics of embedded systems, C programming, the data types, array pointers, and knowledge about the mplab, xide, and xe8 compiler, picsimlab, pix16f877a microcontroller, tactile switch, 16 cross 4 character liquid crystal display, timers, and interrupt. And embedded system is a combination of both hardware and software which is used to perform a specific task. For example, washing machine. There are set of protocols we can organize the way of working and controlling a system. And based on the type of performance and the function requirements, the embedded system is classified into four types: standalone embedded system, real-time embedded system, network embedded system, mobile embedded system. The standalone embedded system, which is of two types, slave and independent. In case of slave, the example is of microwave oven and semi-automated washing machines, etc. And in the case of independent, it is of the fully automated washing machines. And the real-time embedded system, which has airbag as an example, network embedded system as ATM machine or router, etc. And the mobile embedded system, which is of the movable one, and that's the elevator, car, rocket, etc. And the parameters which you have to consider while choosing an embedded system is reliability, cost, power consumption, performance, and memory. These are the things we need to consider while we are choosing the embedded system. And we have learned about the C program in the programming in this internship. The data types, first we have learned about the data types. The data types is of a specific type of data a variable can store, like the integer, character, float, double, etc. Each data type requires specific amount of memory. And the second, we have learned about the arrays. The array is the one which stores multiple values of a single variable instead of declaring a separate variable for each values. In this case, we are going to reuse the square brackets to denote it. And the last thing we have learned in C program is of pointers. The pointer is a the component of the C program. The pointer is used to store the memory address of other function, variable, or even another pointer. And the microprocessor and microcontroller. In the case of microprocessor, all of them have the separate components. They are more flexible, and they are more the complexity, design complexity will be more. And in the case of microcontroller, all the components are present in the single chip, less flexible, and less design complexity is there. While choosing a microcontroller, we need to have some points in our mind. They are in terms of applications, and applications, performance, price, and availability of tools and specific capability. These are the things we need to have in our mind while choosing a microcontroller.
This is Aishwarya Purani, pursuing third year Electronics and Communication Engineering at National Engineering College. On continuing with the presentation, we have used two softwares to implement our project of microwave oven simulation for the internship at Emertxe. They are mplab xide and picsimlab. mplab xide is a software that runs on a computer intended to develop applications for microchips, microcontrollers, and digital signal controllers. This is the software where we have written all the codes and compiled it for further use. picsimlab is a real-time emulator of development boards with integrated mplab x debugger. picsimlab supports some pixim microcontrollers and other microcontrollers too. They have integration with mplab x IDE or Arduino IDE for programming the board's microcontrollers. The PIC microcontroller PIC16F877A is a microcontroller that we have used for our project. It is one of the most renowned microcontrollers in the industry. It is very convenient to use, and the programming is also easier. One of the main advantages is that it can be written and erased many times as possible because it uses flash memory technology. It has total of 40 pins and there are 33 pins for input and output. Then comes the tactile switch. It is one of the type of switch which is widely used that completes an electrical circuit typically when pressure is applied to the device by the user, when which then gives the user a perceptible click or haptic bump in response indicating the current flow. Then comes the CLCD. CLCD stands for Character Liquid Crystal Display. In picsimlab simulator, there are two types of displays, 16x2 display and 16x4 display. In this project, we have used 16x4 display to display 4 modes of microwave oven. There are two kinds of communication modes. They are 4-bit mode and 8-bit mode. 8-bit mode is used for the project. Timers and interrupts in microcontrollers. The PIC microcontroller chip PIC16F877A has three different timer modules. They are listed below as Timer 0, Timer 1 and Timer 2. PIC microcontroller consists of both hardware and software interrupts. If the interrupts are generated by external hardware at certain pins of microcontroller or by inbuilt devices like timer, they are called as hardware interrupts, while software interrupts are generated by a piece of code in the program. They are also known as external and internal interrupts. Now I let down the demo part to Mr. Vimalraj.
Now I'm going to explain the project presentation of a microwave oven. And now that first that a cooking mode function, and there are many sub functions. Many of their operation calls are declared that and microwave and convection modes and the convection mode and the many of the subtasks and that power on screen and which you can use to display that characters. And next a clear display which is used to clear that all that elements present in that LCD display, that CLCD, which can erase every characters present in that LCD. And next that set time, which is basically a timer function, which will calculate that time between that two events. And next door status function, and we have time delayed time display function, and we have set temperature, and here we can set the maximum temperature as 250. So this is our wish. We can may change by our wish. I have set it as a 250 as a maximum temperature in the Celsius form to heat that microwave. And this is my whole logic of that program. Now I can run that program, and that build successful command is set produce result output, and will create a hex file format. We can extract the hex file in a picsimlab file load hex, and we can select the pic changes as a pic 16F877A, which is basically a microcontroller. Here we used this microcontroller 8-bit controller, and this is clock frequency, heater and cooler unit, heater and which is our inbuilt peripherals in that 68878. And to load hex, and we are go to file, and we have choose that particular function and select that hex file from that file. Now select that. Yeah, now the hex file is uh, loaded, and then the powering is on. The micro, the show modes, micro, grill, convection, and first select the micro mode, and that shows that how the power is set, maximum power consumed. And next, so the timer in the minutes and seconds. Here we can wish we can, and I give where we can give the maximum of 59 minutes 59 seconds, and we can demonstrate as I can declare as some small amount of time we, by that is a hash symbol which is used to clear that. You want to clear that, press that. Now now I press a 10, and and to enter that we can press a hash symbol. If we enter that, the fan is rotating and the time is decreasing. And this is the started the microwave generation, and it is started to heat. After the time is finished, the fan is turned and the heat has been generated. Then now the cooking time is up. After the ending the time, the cooking the time is up, is a command is produced. And 2 is a grill mode, which is basically operation of a micro mode. Both it not use a 900 watts power, it uses a minimum power. So we have to put a 6 seconds. If we can pause, resume the time consumed by using that 5, that push button switch. Now the cooking time is up. It's up and show that main. And next is a convection. The number is 3, and it is basically used to preheat that particular food. It asking the temperature. Now if I am enter more than the, but maximum limit is a 250, and this is a invalid temperature. So we want to as said earlier that the maximum temperature is at 250. So we can enter that below 250. Now I can set to that 100 temperature, and that heating time. Now the preheating started from 50 seconds. The time remaining is 50 seconds. The time to increase the speed, I varying the clock speed, so it will very faster, and we will now go to the next operation. And the time, it's a preheating process in the convection mode. You can notice the difference in that speed. By increasing the clock frequency, the time will be, the consume will be less, and it basically represents that baud rate, and it's basically denotes a communication between the two. Now the time is up. And I enter the another time, clear that by using star, and by changing that 10 megahertz frequency, and hex file is loaded hex. So from this we can conclude that our project has made that microwave oven simulation using that mplab xcde and picsimlab and that xe8 compiler, and some of the basic concept of embedded C and the C programming are explained by our teammates. And thank you for the valuable time. Thank you.